Well, welcome back everybody. In this video we're going to go ahead and talk about a optimization to the Xconnect feature that we talked about in the previous video, where we're going to take a look at the Pseudowire class, which is a way for you to kind of templatize the configuration and then have multiple Xconnects configured in order to allow connectivity between multiple PE routers and allow that connectivity to work without having to go in there and manually configure each one individually. So let's go ahead and talk about exactly what I mean. So if we go to CSR3, for example, and we go to show run interface gig 6, we can see that there's an Xconnect configured here. The Xconnect is pretty straightforward configured, meaning that it's a very basic config. But if we were to go to global config and type in the pseudowire-class command, the pseudowire class, and then give it a name, we're going to go ahead and give it a pw_class and hit the enter key. Then we're going to have to specify the encapsulation. So we'll type in encapsulation and then whatever the encapsulation mechanism is going to be. So in this case here it'll be MPLS. And then as soon as we do that, we're going to get a number of different capabilities that we'll be able to take advantage of. So for example, you'll have the control word. There's the encapsulation, again, interworking, where for interworking, if you wanted to go from VLAN to Ethernet or IP to VLAN, you could do that. There is the load balance. And you could load balance the on a per flow basis with what they call the flow label, or flow aware load balancing. You have the monitor, and you could say monitor peer BFD, and that would allow you to monitor the remote connection via BFD peering. Then you'd be able to go in here and type in like preferred path. This is how you would do things like MPLS traffic engineering for layer 2 connectivity. You could also do the protocol, and you could specify the signaling method. You also have the sequencing. Sequencing is going to determine whether or not the other side is going to detect you, and what the sequence numbers are, things like that. You have the status. This is typically tied to connectivity, where if you want to, in the event that there's a link down on the remote end, you could trigger this configuration. So configure status peer topology, and there's also a number of other ways that you can deal with that. Then you also have switching. So switching TLV, if you wanted to allow what they commonly refer to as pseudowire switching, where you can switch from one pseudowire to the other. So that's basically some of the ways that you can enhance this capability. So I'm actually going to come in here and type in control word. I'm going to go ahead and specify the sequencing. I'm going to say both, and it's going to allow, if we do show run section PW, we're going to see that sequencing is both, control word is turned on. If we come back here and we do a status, and we come in here and hit the enter key, it's going to allow that to come on. I think it's on by default. So if we were to do like status and then do redundancy, we could specify who the master connection is. We could also come in here and type in control plane, route watch, if there's a failure, things like that. Then there's also switching. We could turn this on, but that's not really necessary in this case here. We'll type in monitor, peer, and BFD, and hit the enter key. So we're turning on a bunch of capabilities and features. And what we're going to go do is we're going to go and the Pseudowire class do. Now you can see that when we do these things, that because we have debugging turned on, anytime there's a manipulation, there's going to be capabilities turned on. So you can see how this all of a sudden now we're changing the signaling to unknown to LDP. We're changing the sequencing from unknown to both. So you can see that we're turning on flags in the Pseudowire and the Xconnect header, and the route watch is set from 0 to 1. The C bit, or the control bit, used for the control word, so on and so forth. These are turning capabilities on that's going to allow us to scale this solution out. So if we do show run section PW, or I should say PW, we can literally take this guy right here and we can jump over to CSR1 and do the same thing. And I can exit out of that. And then what I'm going to go do is on CSR1, do show run interface gig 3. We can create a .1q sub interface. So interface gig 3 dot, we'll type in 10. Now encapsulation, the encapsulation here, we would specify .1q is going to be 10, for example, but then we type in, so it says that cannot apply VLAN encapsulation VLAN encapsulation configuration if main interface is configured for Xconnect port forwarding. So we can't actually type that command in if we're running an Xconnect on the main interface. So what I'm gonna, instead of doing this, I will exit out and type in no interface gig 3.10. And what I'll do is interface gig 3. We're going to go ahead and I'm going to yank this command off of here. Okay. And now what I want you to do is I want you to pay attention to the logging messages that are show up on CSR3. What I'm going to do is I'm going to type in Xconnect 10.0.0.3, and then I'm going to specify the BC ID of 31, and then I'll type in the pseudowire class and the name of it, pseudowire underscore class, and hit the enter key. It said sequencing specified in pseudowire class is not supported on this interface. Okay, so do show run interface gig 3, or I'm sorry, do show run section PW, and what I'll do is I will come in here and I will just remove that command from the pseudowire class, and do show run interface gig 3. We'll type in interface gig 3, and we'll do Xconnect, and then the peer with 10.0.0.3 with the BC ID of 31, and the pseudowire class will be PW underscore class. Okay, now I'm going to go ahead and I'm going to exit out of that, and you can see that the pseudowire is now up. There's a BFD session created, so I'm going to come over here to CSR3, and I'm going to go to do show run section PW. I'm going to go underneath here and pull the sequencing out, exit out of that, and then do show run interface gig 3, or sorry, in this case it would be gig 6. Interface gig 6. I'm going to pull this command off. I'll type in Xconnect, so that's going to cause the Xconnect connection to come down. So the virtual private wire service, or VPWS, has gone down. You can see that right here. So we're going to come up here and Xconnect to 10.0.0.1 with a BC ID of 31, and the pseudowire class is going to be PW underscore class. And then I'm going to go ahead and I'm going to exit out. So that should trigger a peering to come up, and we should have a connection up, which we do. We're going to give that a couple of moments to finish out its connections and everything else that's going on with that setup. So we go down to here, we do a show MPLS L2 transport for VC, and we hit the enter key. We can see that it's up. If we come in here and do a detail, we can see that there's a lot going on now. So a newer label has been allocated, and we can see that fast failure detection BFD is up. So we do a show BFD neighbors. Nothing directly connected, right? But if we go over to CSR1, we can see that the adjacency is up. We do a show MPLS L2 transport detail, or I'm sorry, in this case it would be VC detail. We can see that it's up and running. So sequencing is received, disabled, send disabled, and we can see that all of the other operations are up and running. We have a BFD peering is configured and operational. If we show BFD and we do summary, nothing shows up. We haven't configured BFD globally. We are just using it to detect a failure, which is kind of cool and how that comes into play, but not too terribly concerning for us right now. So now that we have that in play, if we go back to router 1 and I do a ping to 10.1.3.3, my ping should still work, which it does. If I go back to CSR1 and I do a show MPLS forwarding table, I come down here, 46, I see packets going back and forth, which means everything that I've configured thus far should be operational in these specific terms. So as far as I'm concerned, everything should be working the way that it needs to be, which is what is actually happening. So that's a good sign, right? We've got connectivity, things are operational, and stuff like that. So if we go back over to CSR3, we look through here, if we were to have a scenario where we wanted to take a connection down, for example. So if we were to go to, for example, well actually let's do this on CSR1. On CSR1 we'll go to interface gig 3 and we're going to type in shutdown. So what's going to end up happening is on CSR3 side, what you're going to see is that the peering went down. So that says that the attachment circuit status down. So it says receive status change, and this is coming across in what they refer to as the control word. So the remote attachment circuit. So we're looking at CSR3 now. On CSR1, the circuit to router 1 went down from CSR1. Now unfortunately there's not a really good way in Eve to simulate this where you'd actually be able to trigger it on the CE side, because the interface is actually never, like the line protocol, the link effect, I forget what it's called. It's basically the same logic where if you could basically tell a switch to not pay attention to whether or not a VLAN or a trunk is, or a port is up in a VLAN, you're going to just automatically, those are the auto state, I believe is what it's referred to, where it'll automatically be up and running. And where this one here, it's you have to trigger the PE side, take it down. And so what ended up happening was, by shutting down the link, or I'm sorry, shutting down the interface, that triggered the Xconnect to fail. That sent a message from router 1 or CSR1 to CSR3. The control word is a control plane mechanism that kicks into play here that's controlling this. So that's why control word is important to have running, because now we can see that things are working the way that they're supposed to be. So in the event that the remote peer goes down, you can signal the local side to say, you know what, that's okay, I'm going to go ahead and take the connection down. So if I was to come in here and do a show MPLS L2 transport VC detail, what you're going to see here is right in here is with the label status state machine, local is ready, so local running and up, the remote is not running and is down. Okay, same thing on this side. If we were to do show MPLS L2 transport VC detail, you would see the same thing. We have the local not ready, not up and down, remote ready and up. So just keep those things in mind when we're talking about how the operations come into play. The remote is ready, the local is down. So that's basically how you would correlate this type of a scenario. So what I'm going to do is I'm going to no shut it. And by no shutting it, That'll bring the circuit back up, and after a couple of seconds, CSR3 will receive the update back in, and you can see it doesn't actually show it to you in these specific attributes, but you can see that the connection is up and running and that we're good to go. If we hit the up arrow, we can see that the remote is ready and up and everything's operational. So it gives you a lot of flexibility in terms of the operations and how all those details come into play. So at this point, we're pretty much done with the Pseudowire class. There's really not much more to talk about when it comes to specifically the Xconnect. But it's important to know how to configure them and things like that. So let's go ahead and switch this over to a sub interface, and we'll take the capability of the config that we've already done and flip it over to a sub interface. So I'm actually going to go on gig 3. I'm going to go and bring this guy down a little bit just so you guys can see a sub interface configured. So we're going to go to interface gig 6, do show run interface gig 6, and we're going to go ahead and pull this command off. Notice how the encapsulation MPLS was added. We didn't do that, but the Pseudowire class was configured for encapsulation MPLS. It does it for you automatically. So we're going to go ahead and pull that command out. That's going to take that pairing down, and do show run interface gig 3, interface gig 3, pull this off. So now we're going to go to interface gig 3.10, encapsulation.1q10, and then we're going to go ahead and reapply this to this router here. We're going to go to interface gig 6.10, and we're going to go ahead and copy and paste this command in, but we're going to swap out the peering here. And that should get us a connection through a sub interface. Pretty straightforward stuff for the most part. So we'll let that go ahead and finish its thing. So now it's up. One thing that I want to point out to you is that now that we are underneath, since we are now on a sub interface, if you look right, where is it? I believe it's this. No, it wouldn't be 0 by 7. I'm looking for a specific output that I saw. And I don't see it showing up at the moment. So segment type is now VLAN, where before, trying to see if it's going to show me the output. There's actually a hex value that would show up and tell you the, normally it's located on the VCCV information, but I'm not seeing the actual attribute that I'm looking for. But the segment type is now VLAN. If we scroll up, I don't know if I'll be able to go far enough up. Remember the segment type before was Atom. This was, so the output you're seeing now, this is the main interface variation where you're sticking it in the main interface. So any transport over MPLS. The moment you switch it to a sub interface, you immediately switch it to a VLAN aware variation. So now if I go back over to CSR1, I'm sorry, we'll stay on CSR3. Let me jump out of global config and do a show MPLS L2 transport VC detail. Where is it? There's a specific output here that I'm looking for. And it's not really showing me the information that I want. I mean, it's telling you that it's an Ethernet VLAN because it's pretty obvious that it is. But what I'm looking for isn't showing up the way that I was hoping it would. It might be a different construct, but there's a hex value that'll change during the negotiation of the Pseudowire, that'll change based off of whether it's the main interface, whether it's the sub interface, or whether there's .1q tags being used. That'll change. So let's go ahead and on router 3, we're going to go to interface. Let's go to do show IP interface brief. We'll go to interface gig 2, no IP address. Interface gig 2.10, encapsulation .1q10, IP address of 10.1.3.3/24. And then on R1, we'll do the same thing. Show IP interface brief. Interface gig 0/0, no IP address. Interface gig 0/0.10, encapsulation .1q10, IP address of 10.1.3.1/24. Now the question I have for you is, do you think it's going to work? Do you think that it'll be able to ping? So if we were to go to ping 10.1.3.3, give that a second, yes it does. It pings it all day long. And the reason why it can do that is because of the fact that we've got a .1q subinterface configuration. So the major drawback to this specific design or use case is because when you have a situation like this deployed, you have to map the Xconnect on a per VLAN basis, and you saw that when you have it at the main interface level, it doesn't work as well. So in other words, this doesn't scale very well. And where another mechanism would be to flip over to the newer way of doing layer 2 VPN, which is the Ethernet flow point. And I'll go into some level of detail as exactly what the EFP is designed to do and why it's there. But basically the idea is, instead of having to go to a sub interface, for example, you could just go to the main interface and you can say, I want to match on this specific VLAN type on a per service instance basis. So let's say customer 1 is service instance 1, and then he's matching on one specific VLAN. And I'll walk you through a variety of different scenarios and how that actually comes into play. But these are some of the things that would need to be understood in terms of the operations and stuff like that. So with that being said, ladies and gentlemen, I want to thank you guys for hanging out with me in this video, and until next time, take it easy.